Hello and welcome to Crownsmen Energy. I am your host, Chad Carrier. Coming up on today's show, we have Enlighten Innovation. We are welcoming Steve Reynish, who is the president and CEO of the company, as well as Dr. Steve Hughes, who is the VP of Research and Manufacturing. Enlighten Innovation is a company that's engaged in the research and development of clean energy technology to meet the ever-changing global energy needs and accelerate a net zero world. So we're going to unpack all of that and what exactly that means here shortly. But before we do that, let's welcome in Gaudi Molina to introduce today's sponsors.
Okay, so today we have total combustion. If you are in the oil and gas industry, you know that the regulations to deal with waste gas are always changing and becoming more stringent. Not all companies can afford to go net zero. And because all waste gas is not pipeline quality, combustion is a viable solution. That is where Total Combustion Inc. comes in, with the most reliable combustion solutions on the market. Need to buy or rent waste gas combustion equipment? Need to eliminate unscheduled downtime and lower your operation costs? Call Total Combustion at 403-309-7731 or email them at sales@tciburners.com to learn more. Next up, we have AutoSol. AutoSol solves the challenges of securely collecting and sharing data at scale for industrial SCADA automation environments. Whether your data is on the edge, on your server, or in the cloud, AutoSol can handle it. Regardless of the protocol, device, communication method, legacy asset, or HMI requirement, AutoSol tailors their historical real-time and edge-pulling engines to suit your needs. Their proven platform sets the standard for data delivery with ultra-reliable access to isolated field devices. Visit autosoln.com for more information. You can also check out their interview on episode 30 of Crownsmen Energy. Next up, we have Holly Frontier Lubricants and Specialties, which includes the Petro-Canada Lubricants brand. Petro-Canada Lubricants products and services are proven to maximize equipment performance, productivity, and overall savings. From heavy-duty engine oils to hydraulic fluids, automatic transmission fluids, and gears, oils, and greases, Petro-Canada Lubricants is committed to delivering innovative solutions that deliver value and keep businesses moving. They have dedicated technical expertise, knowledge, and know-how to help customers in the mining industry operate smoothly with improved equipment, reliability, and performance. Learn more at lubricants.petro-canada.com or contact them at 1-866-335-3369 to arrange a call with one of their technical experts. Next up, we also have SolarSet. SolarSet has launched pre-assembled ground-mounted solar systems, including the innovative SolarSet Fold. Their solar systems will power your residential and commercial property, and they can also ship worldwide. Talk to their team to learn if a grid tie or off-grid with battery backup solar system is right for your application. Visit them at solarset.com to learn more. And next up, we have PowerZone. When you need a specialized team of world-class engineers for your oil and gas pipelines, dewatering, or any fluid handling needs, you want to visit powerzone.com. In addition to their inventory of rebuilt pumps, motors, engines, they also have an amazing team to design and engineer your systems, no matter the challenge, no matter the location. Get in the zone with PowerZone. Visit them at powerzone.com. Last but not least, we have Integra. Integra helps pipeline owners and operators reduce risk and minimize costs, delivering the clearest picture of pipeline health using industry-leading ultra-high resolution inline inspection technologies, collecting multiple data sets on one tool run. Data resolution up to 4 times greater than all other ILI tools, human-based data analysis and experience providing the highest quality inspection results available. The Integra ILI system delivers for their pipeline industry partners, whose success depends on safety and reliability. See more, know more. Visit integrasolutions.com to learn more.
Thank you, Gaudi. All right, now let's welcome to Crownsmen Energy, Steve Reynish, President and CEO of Enlighten Innovations, as well as Dr. Steve Hughes, who is a VP of Research and Manufacturing. Gentlemen, welcome to Crownsmen Energy.
Thanks, Chad.
Yes, pleasure to be here, Chad. Looking forward to the discussion.
Well, pleasure to have you both on the show. And before we get into the real heart of the conversation, let's just have a quick introduction from each of you in terms of your roles at Enlighten and your background. Steve Reynish, let's start with you.
Yeah, so my background, Chad, I was 20 years in the mining business, very international roles typically, with a focus on base metals. So copper, nickel, zinc, in many places around the world. And then the second half of my career, I switched to the oil and gas business in Canada, including the oil sands. So a few mining engineers obviously involved in the oil sands. I was one of those guys. Retired from that in 2020 and made the switch to new technology and focusing very much on the energy transition, and joined Enlighten Innovations as president and CEO, as you've said, and having great fun working in this energy transition space and with the new technologies and the breakthrough technologies people like Steve Hughes have helped develop.
Well, and it certainly is an exciting industry, and as you said, a lot of breakthroughs happening. Dr. Steve Hughes, let's have a quick introduction with your background as well with Enlighten.
Sure, sure. Yeah, so my background, Chad, I'm a ceramic engineer by training, did a PhD in ceramic processing, and I've worked the last 20 odd years in technical ceramics. So primarily clean tech and medical devices, medical implants, and been involved in several startup companies, taking technology really from the concept, from the bench, taking it forward to commercialization. And really that's what I'm doing here with Enlighten as well, is taking this this NaSICON, the ceramic technology we'll get into in a second, taking that forward and scaling it up and making it work in the real world.
Great. Well, that's a lot of interesting stuff we're going to get to. So let's do just that. Steve Reynish, let's start with yourself. One of your key mission statements at Enlighten Innovation is enabling breakthrough technologies to energize and decarbonize the world. Let's start there. Just give us a background on Enlighten Innovations as a company and how you are energizing the industry.
So Enlighten Innovations is it's an interesting and diverse team of scientists, engineers, and business people who collectively we've got our hands on this breakthrough ceramic technology, and I know Chad will talk a little bit more about that as we get into this discussion. But that's the breakthrough technology piece, and we're a group of people who want to make a difference at speed and at scale in this energy transition and decarbonizing, energy sources, electrical energy, and grids around the world. So very exciting, but it's all hinged on new breakthrough technology with experienced people trying to deliver that in the right way and at scale.
Okay, well, let's get into that breakthrough technology because it's really fascinating. I think the viewers and listeners are really going to get engaged in this. Steve Hughes, help us out here. Can you give us the backstory on the history of the NaSICON technology? What is it, and where did it begin?
Yeah, sure, Chad. So yeah, it's quite an interesting story, and it started about 40 years ago, so it's not not a new thing.
Okay.
So this class of ceramics that we refer to as NaSICON, that's an acronym that stands for Sodium Super Ionic Conductor, and that's a class of materials, of ceramic materials, that was originally developed by Professor John Goodenough. He won a Nobel Prize for the lithium-ion battery work. Still going strong at almost 100 years old, I believe.
Wow.
So Professor Goodenough's work back in the mid 70s, he discovered this class of ceramic material that could effectively conduct or transport sodium, specifically sodium ions, through the microstructure, through the crystal structure of these materials at an atomic level. And so that was back in the 70s, and a company called Ceramatech picked up the work. They were a spin out from the University of Utah, and they started looking at using the technology for batteries. But back in the 70s and 80s, batteries really weren't such a in vogue technology and in demand. So they pivoted to applying the ceramic to a whole host of different applications. We can touch on that later on, but one of those applications was developing the recovery of sodium metal using sodium polysulfide. And this technology was developed initially for heavy oil upgrading, where there was a waste stream from a heavy oil upgrading process. And in order to recover the sodium metal to go back into the front end of the process, they used this NaSICON ceramic. And essentially, that's what our technology started off as several years ago, was building these electrolysis stacks. So what that means is you're using electricity to pull sodium across the membrane to basically split it off from the sodium sulfide. You make sulfur in one stream, sodium on the other side, and you just recycle back the sodium metal. And then more recently, what we've done in the last couple of years is really understand what happens when you turn off the electricity and now put a load on the back on what is effectively a battery, and let the chemistry reverse itself, and that's the discharge of a battery. So really, we're advancing this technology built off of many years for one particular application in the oil industry, and now we're really optimizing it for this emerging market for long duration batteries.
Okay, well, let's keep going with that, Steve Hughes, because it's fascinating, as you mentioned, from where this technology originated to how where it's come now and where it can continue to go. Doing some research for this interview, can you explain the split operation and how sodium, because you referenced sodium earlier, but how sodium is moved around to get away from transition lines? I guess how can that help us? Where can that take us?
Yeah, well, I think the interesting thing with this battery technology, Chad, is a couple of things. One, this is a chemical engineer's battery. This is for grid scale storage, very, very large batteries. Imagine shipping containers, modularized systems over a few acres. So it really does lend itself quite well to remote locations. Microgrid type thinking, where you maybe want to have a backup power system for several hours to several days in a remote area, and not have to rely upon diesel generators or something else like that, or lithium-ion batteries for that matter. One of the novelties really in our technology is when we run our battery, we do run at a temperature where the sodium metal, when we produce sodium metal, when we charge the battery, it's in a molten state. And what that does, one, it gives us an enormous ability to keep charging the battery, because once you make sodium metal, it just flows away into a tank or reservoir, and you can just keep charging this battery for hundreds of hours, and you can store the sodium metal, and which is quite unique in terms of anybody else's technology. One of the beauties of that with sodium metal is it's a very stable material. So once you've made sodium metal, you've got the electrons captured as sodium metal. It doesn't go anywhere. It doesn't degrade. It just sits as sodium metal until you want to bring it back to the battery and discharge it. But the other nice thing with sodium metal is you can cool it down, you can solidify it into a billet, and you can transport it. So you've got this ability to charge in one location. For example, where you've got an excess of renewable electricity or very cheap electricity, you can make a sodium metal in one location, and then you can truck it, put on a train, or you can transport it any way you like, really, to another site where you can discharge the battery, put the sodium metal in the battery, let it do the reverse chemistry from charging, and it discharges electrons to your grid. So it's kind of a novel way of thinking about doing away with the traditional T&D transmission of electricity over wires. It gives that opportunity to do that.
And I'm thinking of the various applications where this could apply for different industries in terms of power generation. Steve Reynish, let's bring you back into the conversation here. Can you help us expand on what Steve Hughes has talked about, the technology itself, and how your technology is really helping to usher in that new power generation and service the ongoing energy transition that we're hearing so much about?
Yeah, so I would say, Chad, that there's been a great desire to decarbonize electricity grids, and we've seen a dramatic rise in the use of things like solar and wind to do exactly that. And the price of those technologies has come down substantially, and we've seen the adoption of those technologies in many places of the world. However, as that has advanced, it's shown that up to about 70% renewables on a grid can be handled pretty much with the existing infrastructure. But to push beyond that, there is a need for energy storage, i.e., what do we do when the wind doesn't blow or the sun doesn't shine?
Right.
And so the attention has moved from rolling out solar and wind to this question of how do we get beyond 70% penetration, and how do we store electricity for those instances? Steve alluded to we can use lithium-ion batteries, which are now very well established, but only really economically work in the 3 to 4 hour storage range. And so there is a big need that has been well recognized now, but only in the last year or two, for much longer duration storage capability. And we're talking here greater than 8 hours, greater than 12 hours, greater than 24 hours. And so the advantage of a technology like this is subject to just providing storage for the sodium metal that Steve was talking about. We can store energy for 12 hours, a week, a month, or longer. So we've disconnected the power unit from the storage facilities, and that gives a lot of flexibility. And what's interesting to me, Chad, is that brings the technical solution to this intermittency problem, the when the wind doesn't blow and the sun doesn't shine. But it also then opens up, I think, a lot of business opportunities of trading electricity. Let's charge the battery up when electricity prices are very low. It could be at night. It could be during a week where the wind isn't blowing very well. It could be for a lot of other reasons, maybe weather related, maybe not. And then discharge it when the electricity price, has gone up. And so lots of, I think, trading opportunities around that. And of course, the transportation piece that Steve was just talking about. So a very flexible solution, which is becoming recognized actually as essential to decarbonizing the electricity grid.
Well, and it's talking about that need, Steve Reynish, as you've highlighted, and being able to service those power generation needs all the time is, I think, is going to be a major contributor to decarbonizing and moving forward in terms of progress. And you spoke about the market, but let's dig a little deeper in terms of that as well. How is the market, from a market perspective, how is the market coming towards solutions such as yours?
So I think there's a range of parties interested in this technology. The need, if we're going to get, increased penetration on the grid, as I talked about, for long duration. And the sort of people that are interested in that are the solar farm and the wind farm operators themselves. So I can now promise you consistency of supply. But it also appeals to grid operators, as they want to make sure they can keep the lights on 100% of the time. I think it's going to appeal to big trading houses for the trading parts that I just talked about. And it appeals to remote locations, or locations where intermittency of the grid is particularly challenged. And I think there is an important difference here, Chad, between the developed world and the developing world. The mining sector, interestingly, has shown a lot of interest in this for a couple of reasons. One, for remote locations and the need to have power available at all times. That's important everywhere, but in an underground mine, I think it's perhaps even more heightened in that respect.
Absolutely.
But miners are also keen to provide the raw materials for these sorts of technologies as well. So a lot of interest there. And I suppose the other category I would mention is some of the big data, the power users, like the data tech firms, with massive server farms now increasing at an exponential rate, very high usage of electricity, a great need to make it very, very reliable. And typically those companies that show a great interest in being renewable and totally green in their setup. So a range of applications, a range of different customers, same solution, but people come at it from different perspectives. It's quite interesting.
It is interesting, and being able to service, as you mentioned, so many different sectors, industries, and I can't help but think about, as you mentioned, even the cryptocurrencies, Bitcoin mining, just being able to service those massive power demands, and even speaking to emergency situations such as last year in Texas with the cold snap that happened. As you mentioned these things, I just can't help but think about so many applications that are present for a company such as yours.
Yes, I'm glad you mentioned that because yes, we have had some interest from the cryptocurrency guys. Similar reasons, lots of data usage. I think we're only going to see that increase. I'm not an expert, Chad, on cryptocurrencies. Maybe I need to get up the learning curve on that. But we do know they use a lot of power and showing some interest. And the Texas one you mentioned is also kind of interesting when you think about moving electrons around. As we've talked to different utilities, for example, in Alberta, in this last year, there have been extended periods with a high pressure system sitting over us and very little wind, and that's caused issues. Texas is typically the opposite. The wind never seems to stop blowing in Texas, which is great for wind farms, but it does mean the price of electricity can drop to next to nothing, making those businesses actually struggle. And if you get a big outage like the polar vortex you were just talking about, wouldn't it be neat if we could ship in a power supply, by rail or by truck, the sodium that Steve's talking about, hook it up and get the grid functioning in pretty short order. So lots of things I think for us to think about here, but I do think we're at the front end here of, whereas we we still do trade millions of tons of coal around the world and millions of barrels of oil. Maybe we'll be trading, electrons for electricity in the future.
And that's certainly something that I could absolutely see happen in terms of meeting and addressing those energy needs. Steve Hughes, but before we bring you back in, Steve Reynish, I just want to ask one more question in terms of differentiators. Can you talk to me about the differentiators between Enlighten Innovations? I know there's a lot of power solutions on the market, but what sets you apart from the pack?
Yeah, so you're right, Chad. We're not the only ones in this space. There is a bit of a race on, I think, for people to fill that longer duration energy storage space. It's going to be a huge market. I always say somewhere between huge and enormous, but it's in that bracket. But we do think we have some differentiators, and you should get Steve Hughes's comments on this one as well, Chad. But some of the differentiators of our battery is using sodium and sulfur. We use very low cost, highly available, abundant chemicals, and we think that gives us an inherent advantage on the cost side. That mixture is also a very high energy density combination, which allows us to have a very compact battery solution. It lends itself through the separation of the power unit and the storage unit to long duration. We've chatted about that. There's no real chemical reactions happening here. We're talking about the movement of sodium ions back and forth, but we're not forming exotic chemical compounds that need to be worked very hard at the end of their life. So it's a very sustainable arrangement. It's very safe. It fails to safety, low temperature operation, and it's low maintenance. So we think, in short, Chad, it's a very low cost, compact, scalable solution that will compete very well in this market with a number of competing technologies. But Steve, you might add some comments to that one, the differentiators.
Yeah, sure. So yeah, no, maybe taking it a bit more technical, I guess. So yeah, the key points of our battery are, in any battery, Chad, it's all about the chemicals. A battery is just a chemical reactor doing electrochemical reactions. So when you talk about cost of batteries, you've always the bottom line is what is the cost of the chemicals in the battery, and that's where we have a distinct advantage using sodium and sulfur, very abundant, low-cost materials. So the chemical cost of storage, we're probably 4 to 5 times lower than lithium ion, and even greater than that compared to vanadium redox flow batteries, just simply because of the low-cost materials in sodium and sulfur. So that's the starting point for that. And then if you combine that with the energy density, so basically think of that as how many electrons can you get into a given space. We've got an advantage there over the flow battery technologies. And what that leads to is a much lower footprint. We could squeeze in probably to the same, we're about 5 or 10 times smaller footprint for a given amount of power. Compared to other flow battery technologies. And if you think about, for some geographies, that doesn't matter, but when you maybe have restrictions, maybe closer to cities or where land is expensive, that's an often overlooked factor in economics where if land's expensive, that needs to be added to the cost of the system. And our high density, low, very compact footprint lends itself well to that. And I think the last point really, one of our, we've had a few breakthroughs, but one of the real cool things of our battery is it is a flow battery. And we've designed this flow battery purposely because, one, the way we've designed the power stack means that we can take everything apart. It can be totally recycled. Everything's easily, readily replaced. So from a maintenance standpoint, end of life standpoint, you can literally take everything apart and send the plastic components for recycling, the ceramic for recycling. But then the beauty of a flow battery, going back to cost, is you have decoupled power and energy. So in a flow battery, the amount of power, how many megawatts you want, is determined by how many of these ceramic membranes or separators are in the power stack. And that is totally independent for how long you want to store the energy. That's governed by the tanks of the chemicals. So for our technology, we can scale, and that's the beauty of this. We can scale to long durations, many hundreds of hours, simply by adding tanks with cheap chemicals. And that's the distinct advantage with flow batteries over, traditional lithium-ion closed cell batteries. Everything's in that little canister, power and energy. So if you want more energy, you have to overbuild power, whereas we can separate the two. And I think that's the key here to tackling, between 12 hours and many hundreds of hours. How do you do that cost effectively? And I think it's through batteries like ours with cheap chemicals.
Well, let's keep going with that, Steve Hughes. In terms of, you mentioned in your last answer, there's some breakthroughs. Speak to me about some of the breakthroughs that Enlighten is making, because I know there are several. And then, if you can you help give us a basic understanding of just the impact that these breakthroughs are making in terms of a specific example? How many cars would this take off the road, or things of that tangible nature?
Yeah, sure. So I think there's 3 key breakthroughs I'd like to touch upon, and the first one we have touched upon is the NaSICON. So really, at the heart of this battery is this NaSICON, which is a solid state separator. It's not porous, it's not a filter, it's not like a polymeric membrane that's in most people's batteries. This is a solid piece of ceramic that ionically conducts the sodium. So that's a key differentiator. And like I said, we've spent the last 40 years really perfecting the chemistry, getting that to work, Chad. And now really we're at the point where we can produce it at scale, cost effectively. So that's the first breakthrough. The second breakthrough we've already touched upon a little bit is the fact that we use sodium polysulfide, which has got a very high energy capacity, energy density. And we've discovered a way to enable that chemical for batteries by using a proprietary solvent. So in order to have this salt ionically active and actually do what it needs to do as a battery, you have to either heat it up to very high temperatures, several hundred degrees C, which is not not that cost effective and safe. Or you find a way to dissolve it, make a solution of it, and have the ions mobile in that way. And that's what we've done. We've developed a very high energy density catholyte that utilizes this proprietary low cost solvent technology that, like Steve said, is very safe as well. And then the last piece to the battery that really brings all of this together is what we call our infinite anode. So many batteries are limited by how much energy you can put into them to charge them by the size on the anode. So if you've got a metal battery, zinc, iron, for example, you can only put a certain amount of energy in by that's governed by the surface area of the anode, because once the anode is completely plated, you've got no space for any more metal to plate out. You're basically fully charged. In our case, because we've run molten sodium metal, that anode surface is completely being refreshed every time every time a sodium atom, a molecule is being produced, it flows away. There's a fresh surface for new sodium to come along. So really that allows us to continuously charge this battery, and it's really just governed by the size of the sodium storage tank. So it really is a flow battery. So if you put all of that together, Chad, and you look at what does that mean in terms of everyday life, I guess. The average house in the US uses about 30 kilowatt hours per day of electricity. And we've modeled, based on our technology, a 1,200 megawatt hour facility would take up about 3 acres of space, so a pretty compact footprint. And if you think about 1,200 megawatt hours, average house, 30 kilowatt hours a day, that's around about 40,000 average homes. So, probably a city the size of Kelowna, 120,000 people, 150,000 people. Our facility could keep that city lit, keep the lights on for a day with one of these facilities. So you can imagine then rolling this out to many cities elsewhere.
Right, and the scalability of that. It's incredible. I think there's a huge market here for this type of a solution. And you mentioned the safety aspect, which is critical for all of us working in the energy infrastructure, in the energy industry. Steve Reynish, let's bring you back into the conversation here. Speaking from that safety aspect, and there are a lot of changing regulations in terms of what governments and different jurisdictions are looking to implement with respect to the energy transition. Can you talk about those changing regulations and how power consumption needs are changing and how your company is meeting the demand in this space?
Yeah, so I think it comes back to the point we were making earlier, Chad, that the need for longer duration energy storage now it's a must-have if we're serious about this energy transition of the electrical grids, and that's causing some challenges for regulators. It's a different business model that I think they need to get their minds around. It's very different, for example, to have one big base load nuclear power station or coal-fired power station, underpinning a grid. It's very different if we have a large number of renewable energy sources powering that same grid. So as we back out the old systems and bring in the new, it actually becomes more complex, it becomes more intermittent, and we need a solution to that. And the challenge that we're putting to policymakers and regulators is you have a part to play in creating the circumstances and the incentives to make that happen, assuming that's something that you want to do. And they've all been very vocal, typically, and that is what they want to do. And so I think we need some market changes. And you see a lot of that actually in the States, a lot of incentives, a lot of discussion about how to just do that. So I think it is a changing regulatory world. I think it is a a change from policymakers. I'm not sure everyone's got the full answers to that yet, but I think it is going to be a developing space. But certainly, I would say we've reached sufficient critical mass on that change will ultimately follow in fairly short order. And I think the States is probably the market leader, but I think, Canada is looking to follow that as well fairly closely.
Well, a lot of work in progress, and I'm sure things that each jurisdiction can learn from each other. To continue on that, this path of forward progress, Enlighten Innovations, from what I understand, is part of the Long Duration Energy Council. Can you explain, what is this group, what does it do, and why is Enlighten part of it?
Yeah, so I think it's interesting. It does follow from that last point, Chad, that the Long Duration Energy Council is a collection of companies that have come together, more than just companies, that have come together to really make a difference at scale, as I was talking about right at the start. It's not an industry lobby group as such. It's a much broader coalition of technology providers like Enlighten, but also end users. Some of the big mining companies have signed up to it, for example. A number of big industrial businesses have signed up to it. Some of the big tech providers like Microsoft and Google, for example, are members of this council. A whole host of people. It kind of grew out of Europe and North America, but more recently has garnered a lot of interest from places like India, Australia, and Eastern Asia as well. So we're up to about 60 members, Chad. Enlighten was a founder member of this, and it was actually formally launched at COP26 in Glasgow in November of last year. But the uniting principle is, how do we make a big difference at scale, at speed, and has everybody that's showing an interest in this space, wanting to sign up, and so just building on the last point, we have some interesting working groups on regulatory policy. For example, the net zero mine is a distinct, is a separate working group, and transportation and transmission is another working group. So I think it's just an example of lots happening in this space. But we're proud to be part of that, and I think you'll hear more about that going forward as well.
And it all to me, as I hear this, and the progress that you're making with Enlighten and through these other member companies and other member groups, how is this promoting the ultimate goal of ESG, your environmental social governance? How is that fitting into all of these initiatives, and how is companies such as yourself really promoting that that very important aspect to business and to industry?
Well, I think this collection of participants we were just talking about there, Chad, have signed up to the energy transition. They want to be part of that energy transition, which is a greener, less carbon intensive set of technologies of getting electricity to the places that we need it. So that in itself is an environmental enhancement. But we want to do it in an environmentally conscious way as well, which is, one of the attractions of our technology, and it's low footprint, it's great ease of recyclability that Steve was talking about, and there's a lot of social and environmental benefits that spin off from that, and so if I think very broad picture, I think this is going to the heart of one of the big emission emitters, the electricity grid globally. Let's make some significant changes there. And then I think following on from that, we need to look at, cement works and some of the other big emitters, if we're really going to make a difference here in energy transition. It's great for us all to make personal tweaks in in our lives, but it's the big emitters, I think, that are really going to make change here, Chad, at scale. And so electricity generation, backing out the fossil fuels, bringing in the renewable. How do we facilitate that? And a lot of different people signing up to be part of that story.
Steve Hughes, I'm going to pose this question to yourself, and then Steve Reynish, I'll pose the exact same one to you after. But Steve, from your perspective, from the technical end, where do we go from here in terms of how companies such as yourself are pushing this progress forward?
Yeah, I mean that's quite a broad question there, Chad, but I'll give it a go. I think like Steve said, there is now a recognition that long duration energy storage is coming. It's needed. We've got the tail end of the to get to 90% plus renewable electricity on the grid. That's really hard, and it's technologies such as ours, and there are many others out there. And I don't think there will be one solution fits all. It's going to be a spectrum of technologies with us playing a key part. And I think where do we go from here? I think it's really more just more the same. Governments funding and getting involved. We've got to. Steve talked about this. We've got to find ways to monetize. We've got to find ways to make it commercially viable for these batteries, because right now, the way you earn money off a battery is when you discharge, right? You only get paid when you give electrons back. But if really the need for these batteries is to sit there in readiness for an event like in Texas, or maybe only discharge once a week, once a month, you've got to have different policies in place to make these technologies commercially attractive to the private sector, Chad. And I think there are those dialogues happening. And I think, we're obviously forward leaning and trying to get ahead of the curve so that when those things are figured out, we hit the ground running and we've got a technical solution there. So I think from our standpoint, really keen. We're building a demonstration project on the battery right now, Project Infinity, that scales this up to several hundred kilowatt hours, and I think that'll be a great a demonstration of the battery for the world to see. And hopefully in parallel, other folks will have figured out how you monetize the battery and how do you make this a viable commercial solution and pull the two together. And I think I think we'll see a greater decarbonization, which needs to happen pretty quickly.
Well, I think in terms of what comes next, Chad, I think there's a few things that are to watch out for. So I'll start with Enlighten. So we have a technology solution here that we know works. We're looking to scale that up, and a big part of that, Chad, will be the manufacturing side of this business. So we see ourselves as manufacturing these scalable battery units. I think we'll see ourselves looking to work with others, either in the form of joint ventures or other commercial arrangements from a supply chain point of view and from a customer energy provision point of view. So I think there's a whole ecosystem that's going to build up around this, and the establishment of large manufacturing facilities, job creation. We can put these facilities anywhere where there's a piece of flat land, essentially, and so we think that's interesting. I would just make an additional point that on this whole energy transition, the First Nation communities are very interested in this, as you know, and so we're working with a number of different bands in that respect to look at the siting of manufacturing facilities, job creation, and being part of the energy transition from that point of view. So lots to come. I think we're at the front end of something pretty big here, and it'll be interesting to see how it evolves over the next while. And if you were ever minded to have us back, Chad, we'd love to come back and give you an update at some point. But that's where we're at.
Well, we'd definitely love to have you back on the show to talk about that, because I think it's so critical, as you mentioned. There's a lot of key stakeholders that that have a lot at stake in this, and I think it's a critical piece of moving our energy transition. So we would definitely would love you guys to come back on the show and talk about some of the developments and the updates that are happening with Enlighten, because I know there are many, and I know this is just a tip of the iceberg here. But before we wrap up the conversation, are there can you give us just a quick glimpse internally of what's next for Enlighten Innovations?
Well, I think the very next steps we've talked about in terms of this larger scale demonstration, Project Infinity that Steve was talking about, and the manufacturing side, we're seeing that come on, Chad. What we haven't talked about here is this underlying technology, this NaSICON technology, has a range of different applications it can be used for. Today, we've focused on long duration energy storage, which is a very exciting one, but there are others, some of it tied to cleaning up the oil industry, desulfurizing things like marine diesel, lube oil, cleaning up the manufacturing of lube oil applications, and some other chemical applications as well. Steve Hughes, I don't know if you want to talk about those very briefly, but there's more to come, Chad, I guess is the bottom line, and we haven't talked about those today.
Well, Steve Hughes, yeah, please, if you have a few minutes, enlighten us on that.
Sure, no pun intended, right? Enlighten us. So yeah, maybe just briefly, I want to circle back to manufacturing and just like Steve said, what's coming next for us. What I feel as well is kind of exciting for me being a manufacturing guy is, we are going to scale up the manufacturing and the process that we use. Everything that we use in our manufacturing is electrically driven, right? So we've really got an opportunity here to fly the flags ourselves, to build a zero carbon footprint facility, and even utilize our own batteries to ensure that it's powered continuously by renewable electricity. So I kind of get excited by the factory of the future, really, zero carbon footprint battery manufacturing. I think that's really kind of a cool thing if we can get there, Chad. And I think our battery is going to help us do that. And then just lastly on the technology, it's NaSICON is a platform technology. It's all about moving sodium ions back and forth across this ceramic membrane. And like Steve said, carbon fiber, we've got active research groups, areas with carbon fiber and recycling old lube oils, but we've also got some really innovative work going along in producing sodium chemicals and green fuels using the same ceramic membrane and the same base technology, and even got some pretty early stage ideas in hydrogen and ammonia, which people talk about as well as being very next generation fuels. So I think, yeah, watch this space for NaSICON and Enlighten.
Chad, as you'll remember from your grade, whatever it is, 8 chemistry in school, sodium is right next door to lithium in the periodic table. So some similarities in terms of how it reacts, but far more abundant, as we've talked about, and far easier to find and to use.
One is taking that, as you mentioned, that abundant and safe resource and really coupling this into this transition. And I think, as you both mentioned, Steve Hughes, I really like that, that watch this space aspect, because it is so true. It's a space that is critical, it's needed, and companies such as yourself are really helping to push that innovation forward. So I thought it was a wonderful conversation today. I really appreciate you gentlemen coming on the show. It's a topic we'd love to bring you back on, because we can talk about it at length for hours, just as everything changes and seems to really move forward. But thank you so much for taking the time to come on Crownsmen Energy today.
Thank you, Chad. Good discussion.
Yeah. Thanks, Chad. Appreciate the time. Thank you.
Yes. Well, thank you to you both. And before we wrap up today's episode, conversations such as this today are so critical in terms of moving the energy industry forward. So if you want to get involved in Crownsmen Energy, follow us on all our social media platforms. You can email us, get in touch, get involved with Crownsmen Energy in any way possible. So from all of us at Crownsmen Energy, thank you so much for taking the time to watch our show, and we'll see you on the next episode of Crownsmen Energy.